Hello, this is DJ Joseph from Brainstem Academy and also your trusted IGCSE chemistry tutor. Now, today we'll be working on Cambridge IGCSE for chemistry, paper 4, and it's from October, November 2025 season. And just to let everyone know, for this season, okay, our students from this season, we have a total of 25 AA star students. Okay, if you don't believe me, you can check our pages and locate these names, okay? Right? And yeah, we have the name list with their school names and all. Okay, so there's a total of 30 A-star students and 12 A students. And actually, right, these students, some people thought that they are special, but I don't 100% agree with that, okay? Because most of them also struggled initially. But of course, under proper coaching and guidance, they have managed to turn around their grades. Okay, but of course, they put a lot of effort into their studies in order to make that possible. Okay, so if you are struggling with the subject and you're willing to learn, all right, you're willing to put effort into this subject and you feel stuck, okay, you want help, you can seek us for help. Okay, what you can do is you can just go to our pages and or just visit our website and yeah, and proceed from there. Okay, so now today we'll be working on paper 4. Okay, paper 4 from October, November 2025. Okay, so this is the exam paper that my students take, okay, for that season. Now, anyway, okay, so first question, atoms and ions are made from particles called electrons, neutrons, and protons. So complete table 1.1. Now, protons have a relative charge of +1, neutrons have no charge, so 0, and relative mass, for neutron and proton, they have the same mass. So relatively speaking, relative means like compare, it's a 1-to-1 ratio. Okay, 1-to-1 ratio. Now, just remember for relative charge, you must put the plus minus symbol, okay, or else they'll mark you wrong. Okay, next, table 1.2 shows some information about some atoms or ions. So complete table 1.2. Okay, some concepts to clarify. First, know that atoms are neutral. They should have the same number of protons and electrons. Cations have more protons than electrons, and anions have more electrons than protons. Okay. So now, apart from that, you also have to know the standard representation, which is usually represented in this form, which is the element symbol, and then we put the sum of protons and neutrons on top here, and protons at the bottom. Okay. And then of course there's a charge. The charge will depend on this. Okay, it will depend on the difference between number of protons and electrons. Okay, regardless. So first option, this chemical should have 18 electrons because it's positive 2 charge. So 2 more protons and electrons. This chemical, the sum of proton neutron is 19. So we take 19 minus 9. Okay, that's the number of protons. And that equates to 10 neutrons. And for the last question, okay, so the sum of protons and neutrons is 70. The number of protons is 8. And then the symbol, okay, to know the symbol, we have to look at number of protons. Okay, the proton number is also known as the atomic number. It will tell you which element is this chemical. Okay, so number 8 will be oxygen. Okay, oxygen. And the charge here should be -2. Okay, -2 because there's 2 more electrons than protons. Okay, next. AR, the relative atomic mass of an element, is the average mass of its isotopes compared to one atom of isotope X. So what is the isotope? Carbon 12. Okay, carbon 12. Right, this from the definition, and there's here a history behind it. If you're interested, you can search about it. Okay, there's a history about why they use carbon 12. Okay, I'm not going to explain that further. Let's continue. A sample of magnesium consists of 2 isotopes with mass numbers 24 and 26. So they want you to calculate the percentage abundance of this isotope with mass number 24. Okay. Now, as we have said earlier, the AR is the average mass of isotopes. Okay. Now, the problem here is we don't know what is this, okay? We don't know what's the percentage abundance of isotope of magnesium 24. Okay, so we let this be X, okay? We let this thing, this phrase be X, okay? The percentage abundance of isotope of magnesium with mass number 24. Okay, then what about magnesium 26? Okay, the percentage abundance of magnesium 26, it will be 100 minus X. So why? Because total percentage abundance should be 100. Okay, should be 100. So 100 minus X. Okay, using this, we can just plug it in into our formula. So remember, AR is the average mass of isotopes. So what we do is we just take the mass number, multiply by the abundance, and we sum them together. Okay, sum them together and divide by total percentage. That's 100. Okay, you can see that this is just mean formula. Okay, average formula. Now then we just solve for X. Okay, so 2430 equates to negative 2X plus 2600, and it will be 170 equates to 2X, and X should be 85%. Okay, so it's 85%, right? 85%. You can also check the answer by just putting this number back. So one is 85%, one is 15%. You plug it into the formula and check, does it make 24.3? Okay, that's how you check your answers. Okay, next, one of my favorite questions. This was within my predicted question list actually. And yeah, just to let you know. Okay, so this is a list of substances with different melting point, boiling point, electrical conductivity. Okay, that's the data. Okay, so just some general principles first. Okay, first of all, here's how we think. Okay, here's how we analyze. We see what are the ones that are different. Okay, the first, like more obvious to students, right, is the fact about G and D. Okay, G and D have very good electrical conductivity in both solid or molten state. Okay, so that should give us the idea that they are most likely metals. Okay, they are most likely metals because metals have good electrical conductivity in both solid and molten states because electrons are free to move. Okay, now, and then we look at one special case, which is this one, right? It has poor electrical conductivity when solid, but good electrical conductivity when molten. So it means that this must be an ionic compound, okay? Because ionic compounds in solid state, the ions are not free to move to carry the charge, but in molten or aqueous state, the ions become free to move, so they can carry the charge forward. Okay, so the rest have poor electrical conductivity, no matter the state, means that they are most likely non-metals, covalent molecules. Okay, so that's how we approach this question. Okay, then apart from that, we can also look at the melting point and boiling point. Now, general principle, okay, general principle. If you see a substance with melting point greater than 500, it is usually a giant structure. Okay, of course, this is just general principle, but still, it's kind of useful for us to know, where you can see that this one, A, might have been a giant covalent structure, and then our G, okay, is giant metallic, okay, giant metallic. And C also most likely, oh, that's ionic, right? Giant ionic, okay? So we have a giant covalent, this one is giant ionic, this is giant metallic. Okay? Now, that will be how we approach this question. Of course, it's not absolute, okay? We have to just look at the question and answer accordingly. Okay, so first thing first, you must know the state of substance at particular temperatures. Okay, so the general rule is like this. Okay, allow me to draw a number line, about a temperature number line. Okay, general principle. If the temperature is located below the melting point, the substance exists as a solid. If it's located between the melting point or boiling point, the substance will be a liquid. And if the temperature is above the boiling point, it will be a gas. Okay, so using this information, so which one is having boiling point lower than 25? So from here, okay, the list here, we can see that it's B, okay? B, 25 is greater than negative 182. So B. Next is a solid consisting of simple molecules. Okay, a solid. Now, it cannot be A. We just mentioned that this must be giant, okay, given the high melting point, right? And then this one is a gas, B is a gas, right? So EF, okay, EF, but E is a liquid, okay, 25 is between the melting point and boiling point. It's F, okay, because 25 is below the melting point. So the answer is F, okay? So the principle is a simple molecule should have poor electrical conductivity, and the melting point and boiling point should be below 500. And then plus D is a solid, so we just look at the melting point, okay? Now, then 3, a metal which is a liquid at 25. So it's D, okay? We just mentioned that this must be a metal, okay? It has good electrical conductivity, and plus it's a liquid, okay? Given that 25 is between the melting point and boiling point. Okay, now, so next, identify which substance is a giant covalent structure. So it's A, right? It's A, as mentioned earlier. So why? Because it has such a high melting point and boiling point, as well as given that the electrical conductivity is poor, okay? Even during molten or, okay, during molten or solid, okay, it's low. Then ionic compound, okay, we just mentioned it will be the substance, which is C, okay, C. So reason because it only conducts electricity during molten. Okay, you must say the word only, right? You must say the word only. If you don't, we can also see other data. There are some substances that can still conduct electricity during molten. So we can separate these because we can see it only conducts electricity during molten. Okay, now, oh, there's the next question. Oh, that's fast. Okay, but okay, let's look at number 3. So this question is about aluminium and other metallic elements, and we can extract aluminium from purified bauxite by electrolysis. So this is the diagram of the electrolytic cell. State the name of the aluminium compound present in bauxite. That's aluminium oxide. Okay, bauxite is just aluminium oxide. Or name the substance that purified bauxite is dissolved in before electrolysis is carried out. It's called cryolite. And name the substance that is used for the positive electrodes. That's graphite. And the ionic half equation for the production of aluminium at a negative electrode. So for this one, it's like the electrolyte contains aluminium ions and oxide ions. So negative electrode will attract the aluminium ions and they undergo reduction that forms pure aluminium. Okay, next. Aluminium is above zinc in the reactivity series, but when you place a piece of aluminium foil to zinc sulfate, a reaction is not immediately observed, even though aluminium is above zinc in the reactivity series. So why? Okay, so because of the unreactive oxide layer. Okay, remember that aluminium, a bit special, although it has a high reactivity, however, it is coated by a layer of unreactive aluminium oxide. Okay, so an unreactive aluminium oxide layer. Okay, you can say further, you can see there's a coating. You can say that basically it kind of like prevents the aluminium inside from reaching the zinc ions. You can see that also. Okay, then for question 2. After a few minutes, a displacement reaction occurs between aluminium and aqueous zinc ions. So they want you to complete the ionic equation for this reaction. Okay, there are 2 ways to do this question. The first one is just turning them half, then you combine them again. Okay, so we see that aluminium turns into aluminium ions that donate 3 electrons. We can see that zinc ion gain 2 electrons to become zinc. How do I know about the electrons? I look at the charge, okay? I look at the charge. So to form +3, it must lose 3 electrons. To turn +2 to neutral, it must gain 2 electrons. Okay, to combine half equations together, we have to turn the number of electrons the same. So that is done by multiply this equation by 2. So I get 2Al, becoming 2Al3 plus and what we call 6E. And this one is times 3, I get 3 zinc, 6 electron, 3 zinc. Okay, so I combine them together. Combining as of reactants and reactants come together, products and products come together. Okay, so I put the reactant mixture on my left-hand side. I put my product mixture on my right-hand side. And then we cancel electrons because electrons are the same. Okay, they are the same term on both sides. So we can cancel that. So you can see the coefficients here. So 2 aluminium, 3 zinc. Okay, that's the first way to do it. Myself, I prefer the second way. The second way is I think about transaction. Okay, what do I mean by that? I see that zinc gains 2 electrons. For each zinc, I see that each aluminium lose 3 electrons. So to achieve a happy relationship together, there must be 2 aluminium that gives out 6 electrons, and there must be 3 zinc that basically gain 6 electrons. Okay, so using that information, I understand the transaction here is 6 electrons in total. Okay, so that's how I can balance this equation without doing the steps on the right. Okay, then next, take the oxidation number of zinc in these two. Okay, so oxidation number is basically, you can think of it as charge. Okay, so this is +2, this one is no charge, so 0. Okay, then define reduction in terms of oxidation number. So oxidation number decreases. That's all. Okay, that's called reduction. And state the meaning of delta H. That is just enthalpy change. And state what can be deduced from the reaction from the negative side. So it means that the reaction is exothermic. That's all. Okay, negative symbol means the reaction is exothermic. Okay, next. Gallium has many similarities to aluminium, and gallium trioxide is an amphoteric oxide. So what is meant by the term amphoteric? It means a substance that can react with both acid and bases to form salt and water. Okay. Now, then the reaction of gallium trioxide with aqueous sodium hydroxide forms a salt, which contains a negative ion GaO2 minus, and the only other product is water. So write a simple equation for this reaction. Well, gallium trioxide is Ga2O3. Sodium hydroxide is NaOH. Okay, they say it forms water. Okay, and also it forms a salt, right? Okay, in general, what is a salt? A salt is a substance created, okay, it's basically an ionic compound, usually created from the acid. Okay, usually the anion came from the acid, usually. And the cation is either a metal or an ammonium. Okay, and this metal usually came from either the metal itself or from a base. Okay, it's either from the metal itself or from a metallic base. Okay, so from here, the relationship here is this sodium hydroxide is acting as a base right now. Okay, and this gallium trioxide is currently behaving like an acid. Okay, it's currently behaving like an acid. So from the idea of that, right, we know that the cation is Na plus coming from the base, And they told us already the N ion is GaO2 minus, okay, GaO2 minus. So how do I get this formula? Na plus GaO2 minus, I swap the numbers, okay, plus 1 minus 1. I swap, I get 1-to-1 ratio. Okay, now let's balance the equation. So seems like there's 2 gallium, okay, two gallium. Hold on, let me double check. Am I doing it correctly? Yep. Okay, to balance this equation, I'm seeing 1 Na, 1 Na. I'm seeing 2 Gl. Oh, that means I need to have, let's say I put this number as 2. That means I must have 2 sodium and water here. Let's count. There will be 5 oxygen on the left currently, and on the right there should be 4 plus 1, 5. Okay, hydrogen is balance, oxygen balance, sodium balance. Okay, so it has to be this ratio, right? 1, 1, 1, 2, 1, 2. Okay, 1, 2, 1, 2. So I balance it by looking at gallium. There should be 2 gallium, and when I put a 2 here, that should affect my sodium, and I double check my answers. That's how I can get this answer. Okay, next question. They use the formula of gallium-3 bromide and gallium-3 sulfate. Okay, so this one is just a simple swap and drop method. So bromide is a group 7 element, so it will form -1. So we swap and drop, you get Ga, Br3. And sulfate is 2 minus. So swap and drop, we get Ga2 bracket SO4 3. Swap and drop. Okay, next. Gaseous chlorine reacts with gaseous phosphorus 3 chloride to form gaseous phosphorus 5 chloride. And the reaction is a reversible reaction. When the 3 gases are in a closed container, the system reaches equilibrium. So describe a reversible reaction and equilibrium in terms of the rate of the forward reaction and the rate of backward reaction. So that becomes equal. Okay, they are equal, right? The rates are equal. Okay, but for this year, I can write like this, but for most years, please do not write like this. Okay, please write in full. Rate of the forward reaction is equal to the rate of the reverse reaction. Okay, then the concentration of reacted products basically stays unchanged, right? They stay unchanged. Okay, this year should be quite lenient because they give you the terms. Normally, most years, if they don't give you the terms, please write in full. Okay, please write in full. Okay, so next, complete the table by using the word increase, decrease, or no change. Okay, for these kind of questions, usually I will advise my students, do rate first. Okay, rate is easier. So rate is based on collision theory. We know when pressure is decreased, rate must decrease. Okay, right? Pressure decrease, particles basically what we call, there's a lower, what we call less number of particles per unit volume, and then they collide less frequently, so the rate decreases. Okay, but equilibrium concentration is a different story. We have to think about equilibrium position shifting. So if we decrease pressure, that should favor the site with more gas. Okay, that should favor the site with more gas. And looking at the equation, on the left, there are 2 gases. On the right, there's only 1. So that means if you shift the equilibrium to the left, that causes the concentration of the products to decrease. And then catalyst will not affect equilibrium, okay? It will not affect U or concentration of the equilibrium. So no change. Okay, next question. When the temperature of the equilibrium mixture is increased, we notice that the equilibrium concentration of PCl5 starts to decrease. So what is the conclusion about the forward reaction can be made from this information? Okay, I believe a lot of students will have problem with this question. So here's how we think. When we increase temperature, it should favor the endothermic direction. Okay, it should favor the endothermic direction. Now, we don't know will it go to the left or right since they didn't tell us the information about the energetics. But we see PCl5 decreases. Now, what does it mean when PCl5 decreases? It's the product, right? It means the equilibrium position must have shifted to the left. So why does it shift to the left? Because backward reaction is endothermic. So the missing puzzle is this one. This is the missing puzzle. Okay, we use this linear reasoning. Okay, increase temperature, favor endo. We see PCl5 decreases, meaning the equilibrium must have shifted to the left. Okay, but of course, this question, they want forward reaction. So let us do that. It means that the forward reaction is exothermic. Okay, now, then this question. Ethene reacts with chlorine to form 1,2-dichloroethene. Table 4.2 shows some bond energies, and they want you to use the bond energies to calculate the enthalpy change. So use the following steps. Okay, for this question, there's the long way to do it, there's the short way to do it. I'm going to show you the long way to do it because that's generally safer to do. Okay, the long way to do it is how most students are taught, which is just break all the bonds. Okay, just break all the bonds and reform all the bonds. Okay, so remember, in a reaction, the bonds in the reactants must be broken. Okay, so the currency is here. Okay, the values are here. We have to calculate that. So when we break this bond, it costs us 610. When we break these bonds, it costs us 4 times 410. Okay, and we want to break one more bond, which is this one, CL bond, that costs us 240. Okay, so we sum them together. That should give us 2490. Okay, second is we need to form all new bonds. Okay, all the new bonds. So here we have 1, 2, 3, 4. They cost us 410. Okay, so there's 410 times 4. We need to form this bond, CC bond. So it gives us 350. We need to also form this bond, which is CCl, that costs us 340, but there's 2 of them. So when we sum this together, that should give us 2670. Okay, so 2490, 2670. Okay, then to find the enthalpy change, we just need to use the formula bond breaking minus bond formation. Okay, so use our previous answers. 2490 minus 2670. That should give us negative 180. Okay, so there's also the fast way to do it. Okay, the mark scheme actually says, okay, you can do the fast way. The fast way is like this. The fast way is just we focus on the real bonds that are broken. Okay, like basically the net. What is the bonds that are changing? If you notice, there are 4 CCH bonds. They are not changing. So we can actually skip these 2. Okay, we can just not calculate these 2. Is that okay? Actually, yes, you can do that. So we just have to calculate these 2 bonds and these 2 bonds. And we can also still find the same answer, negative 180. Okay, now next, this is covalent molecule. Chlorine reacts with nitrogen to form nitrogen trichloride, and they wanted to complete the dot and cross diagram. They wanted to show outer shell electrons only. Okay, so very simple. Nitrogen is from group 5. Means that it has 5 outer shell electrons. It will need 3 more. Okay, it will need 3 more to get a 4 outer shell. Okay, when we need 3 in covalent bonding, it means that it will share 3. Okay, so when it happens, once it shares 3, it will left with 2 non-bonding electrons. So it looks something like this: 1, 2, 1, 2, 3, 5 electrons. Fluorine is a group 7 element. It means that it has 7 outer shell electrons. It will need to share 1 more, or should I say it needs 1 more electron to get a 4 outer shell. So when it happens, 6 non-bonding remaining. Okay, so chlorine contributes 1 electron for sharing. So left behind 6 non-bonding electrons. Okay, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's all. Okay, next, when magnesium carbonate is added to dilute hydrochloric acid, a chemical reaction occurs, and the equation for the reaction is shown below. Give 2 observations when magnesium carbonate is added to dilute hydrochloric acid. Okay, so when you add this, you will see bubbling because carbon dioxide is formed. You can also use the word effervescence. You can also use the word freezing. Okay, and number 2, we see the solid disappears. Okay, solid disappears because magnesium carbonate is dissolving, okay, into the solution. Okay, next is stoichiometry. Calculate the volume of CO2 that is produced at room temperature and pressure when 50 cubic centimeter of 0.1 mole per cubic decimeter hydrochloric acid reacts with excess magnesium carbonate. Okay, so to do this question, very simple, 3 simple steps. We will have to find the number of moles of hydrochloric acid first. So equation is mole of a solution equates to concentration times volume. So they should give us 0.1 mole per cubic decimeter. Okay, but we have to be very careful. We have to convert this to cubic decimeter first, which is by dividing by 1000 before we do the calculation, or else we cannot cancel the units. So we get 0.005. Okay, then second step, we have to find out the number of moles of CO2. So what we can do is we can just use the equation. So the equation says that 2 hydrochloric acid, okay, 2 hydrochloric acid will make 1 CO2, okay, for the equation. Therefore, if I use 0.005, right, it will make half of it, so 0.0025. And for the last question, we can find the volume of CO2 by using the concept of molar volume because this is a gas. So we take the number of moles multiplied by molar volume, which is 24. Okay, but this is cubic centimeter. 24 is for cubic decimeter, so I'll use 24,000. Okay, this is changed to cubic centimeters already, times 1000. Okay, so using this, we should be able to find our answer. Allow me to calculate. So that gives us 60 cubic centimeters. Okay, question 5. The question is about metallic compounds, and insoluble metal salts such as lead-2 sulfate are made by precipitation. When aqueous lead-2 ions react with aqueous sulfate ions, a precipitate of lead-2 sulfate forms, and a sample of pure lead-2 sulfate can be obtained from the precipitate of form. Okay, so they want you to write an ionic equation, not a typical equation for the precipitation, and include 6 symbols. Now, for ionic equation for precipitation, generally it will follow this format: AQ plus AQ becomes solid, usually, okay, in general. So these aqueous lead-2 ions married together with these sulfate ions, and they form this inseparable solid couple, okay, solid compound, lead-2 sulfate. Okay, then next 2 questions are of the same principle, actually, which is, they were to name an aqueous solution containing lead-2 ions and sulfate ions. Okay, so what does it mean? You have to use a soluble lead-2 and soluble sulfate solution. Okay, if it's insoluble, it cannot make a solution of that. So how do we know which are soluble? We remember the simple mnemonic SNAP. Okay, SNAP salts. So SNAP stands for sodium. Okay, sodium sulfate, for example, is soluble. N stands for nitrate, so lead-2 nitrate. Okay, nitrates are soluble, that's why they are quite popular in chemistry. And we can also give other answers like potassium sulfate, which is also soluble. Okay, the P stands for potassium. We can also use ammonium, okay? Ammonium sulfate. The E stands for ammonium, okay? So sodium, nitrate, ammonium, potassium. Okay, next, state the general term given to an insoluble substance that remains on the filter paper. That's called a residue. And how can you purify this lead 2 sulfate after filtration? Okay, just honestly, because it's already a precipitate, okay, it's obviously a solid already. All we have to do is just wash with distilled water and just dry it. Okay, maybe you can dry between sheets of filter paper. That's all. Okay, filter, wash, and dry. Okay, next, copper is a transition element, and we have a list of properties of copper shown below. Give 2 properties for the list that show how copper is similar to metals in group 1 of the periodic table. Okay, so all metals, doesn't matter if it's group 1 or pressure elements, have good electrical conductivity, okay, as well as the ability to form basic oxides. Although not always, but for copper and group 1, they form basic oxides. Okay, some metals form amphoteric oxides like zinc oxide and aluminium oxide, and also just now the gallium 3 oxide. Okay. Now, so these 2 are general properties of metals. And for 2 properties on the list that show copper is different. Okay, so copper is a treasure element. So treasure elements have 3 unique chemical properties. Number 1, they have variable oxidation states. Okay, so copper can form +1, +2 ions. Number 2, they can form colored compounds. Okay, colored compounds. So for example, copper 2 sulfate is blue. Okay, and then lastly, they can act as catalysts. Okay, copper can act as a catalyst, but these 3 properties are missing in other other groups of metals, like group 1. Okay, I think you can also put the form soluble salts under 1. Okay, but disclaimer, not all copper salts are soluble. Okay, but some of it are soluble, like copper 2 nitrate, copper 2 chloride, and copper 2 sulfate. Okay, so we can pick either of these answers. It's just 1, 2. Next, this question is about organic compounds. So they have this following composition by mass. We have to find out the empirical formula. Now, to turn the information to empirical formula, pretty simple. You just have to first list out the mass ratio. Okay, list out the mass ratio. So the percentage by masses tell you the mass ratio actually is like 50% to 5.56% to 44.44%. Okay, it can be in grams, it can be in kg, but basically there's a mass ratio. Then we can turn this to mole ratio. So what do? We divide by molar mass. Okay, use a periodic table. Carbon is 12. That gives us, hold on, let me check. That gives us 4.17. And hydrogen is 1. That gives us the C number. And oxygen is 44.44 divided by 16. That gives us 2.78. Okay, our third step is we have to change this to a simplest whole number ratio. Okay, or at least simplified. Okay, simplified whole number ratio, because the previous row looks very confusing. The trick here is just divide by the smallest number. Okay, because we are comparing. So that being 2.78. We realize that it is 1 to 2 and then 1.5. Oh, okay. So some students are stuck at this question actually. Okay, from my batch of students, I heard from them after exam. Okay, so the point here is, please remember that this is just ratio. At the end of the day, it's just ratio. So we can just multiply by 2. Okay, complete the half by multiplying the whole expression, the whole ratio expression by 2. So that's how we can get whole numbers. So it's a 3 to 4 to 2 ratio. So it's C3H4O2. Okay. So it seems that our third step, we can only get a simplified mole ratio instead of the whole number. And only our last step, we can get a really simplest whole number ratio. Okay, so anyway, next. Organic compound R has the empirical formula CHO and a relative molecular mass of 116. So find a molecular formula. Okay, the point is, remember that molecular formula is actually just the empirical formula multiplied by a multiple. Okay, you can multiply 2, multiply 3, that's how you get molecular formula. Okay, so we can find N by taking the mass of the molecular formula divided by the relative mass of the empirical formula. So we are given this data already. That's 116, okay, relative molecular mass. Empirical formula we have to find ourselves. So 12 plus 1 plus 16. I got these numbers from the period table. That should give us 29. And if we were to compute this out, we get 4. But don't forget, we have to put it in back to our formula. So CHO times 4. So we get C4H4O4. C4H4O4. Okay, next. Carboxylic acids react with alcohol to form esters. So name one other product that is formed when carboxylic acids react with alcohol. So if you look at the functional group, COH and alcohol, they react via a reaction called condensation reaction, where water is removed. Okay, water is removed. The catalyst here that we use is concentrated sulfuric acid. That's usually what we use. Okay, but from the mark scheme, they use acid. Okay, but usually most of the time we use concentrated sulfuric acid for this particular process. Okay, then we have this ester S that has this structural formula. So to figure out what carboxylic acid and alcohol that can react together to form this ester, what we can do is we can just cut this ester in half. Okay, cut at the ester linkage. Some teachers will ask you to cut here. Some teachers will ask you to cut here. Actually, for IG level, it doesn't matter. So the next thing is you have to recognize the components. So this part actually originated from the alcohol. Okay, that's the remainder of the alcohol. And the alcohol, okay, it has 4 carbon. So it's butane 1O. Okay, turns out they are very strict. You must mention 1. Okay, you must mention 1. If you don't, they will mark you wrong. And then for the other side, this is a 3-carbon carboxylic acid. Okay, if you're wondering how did I get this conclusion, I just reverse the thought process. Okay, I think about the functional group of esters is created from this. So I reverse this thinking process. So I know that this part comes from the carboxylic acid. So that's 3 carbon. So it's called propanoic acid. Okay, now, next. So here we have a polymer structure. So need a type of polymerization that is used to produce this polymer. Okay, we can see that this is it's not a polyamide nor a polyester. Okay, and we can see that it has these carbon-carbon single bonds, like, going throughout the length of this polymer. So it's a saturated, what we call a molecule here. So it's actually formed from addition polymer. Okay, addition polymer. So suggest why is it not possible to write the molecular formula? Well, molecular formula tells you all the atoms and all the elements, but it's not possible for this polymer because, well, the length is indefinite. We don't know how long is this. Okay, right? It can be 200, it can be 300, it can be 400. We don't know. And still the number of monomer units that are needed to make this part of the polymer. Well, we can see that there are 3 repeating units. Okay. Right, 3 repeating units. So 3, okay, 3 monomer units are needed. You may say, how do I know that it's 3, not 6? Okay, so you have to understand that addition polymers are usually made from alkene monomers. Okay, alkene monomers. That means they have this carbon-carbon double bond. Okay, so I know that the main chain here, this originated from this structure. Okay, regardless, I'll draw the display formula. Okay, but the keyword here is display formula. It means all bonds must be shown. All atoms must be shown. So we have to treat this like this. Okay, we have to draw. But we have to show this CH3, right? We have to show all the bonds. Okay. Like what I'm drawing here is this section came from this section. Okay, we just put the single bonds back. And these two arms, okay, these two arms actually came from these two structures. Okay, CH3, CH3. Okay, now let's move on. Okay, next. Figure 6.2 shows the general structure of an amino acid. So they want you to complete to show all the atoms and all the bonds of the two functional groups of amino acids. Okay, amino acids are called amino acids because they have a carboxylic acid functional group as well as an amine functional group. That's why they are known as amino acids. Okay, so amino carboxylic acid. Okay, next. On this figure, draw a circle around one amide linkage. So amide linkage is a CONH, okay, functional group, CONH. It's amide linkage. And say the name given to natural polyamides made from amino acids. So there's proteins, okay? Amino acids from proteins. And that's all for this discussion. So if you are struggling in IGCSE chemistry and you are willing to put in the effort and you wish to get more support and help, okay, for our online tutoring, so you can just visit our website or just visit our social media pages and just reach us, okay, from there. So I'll see you in the next one.